This is part two of my solution for problem one on our rational functions word problem. And what I'm going to do is just run down what we've done so far. We actually wrote this equation, and the way that we did it was we first considered what we're looking for in this problem, which is the average speed of the car during the day. We're going to use miles per hour as our unit, and I'm going to represent this thing that I don't know that I'm trying to find as R. And first we just started with the basic rate equation, and we applied that to the daytime and then also to the nighttime. What this basically says is that during the day and during the night, the distance is the same. It's just 120 miles, and we're going to leave it we're just going to leave it as D right now, but we can substitute that 120 in when it makes sense. Also, at nighttime, it takes 3/5 of an hour less time to do the same trip than it did during the day. And the rate of speed of the trip at nighttime is 10 miles per hour faster than it was during the day. And we solved for t over here so that we could eliminate this t using substitution. And now I'm left with this rational equation that I need to solve, and I'm going to do that down here. So the first thing I want to think about is this messy denominator. I see there's a fraction subtraction problem, which means I need a common denominator. And my denominator is going to need 5 and r in it, both factors that we see here. And so my left side of the equation is unchanged. But on the right side, I'm going to just find the common denominator and do the subtraction like that. So think about how you would find a common denominator and do this subtraction. You should end up with a result like that. Okay, so we found a common denominator, and we subtracted fractions. So now we've got a rational division problem over here on the right-hand side, which means we have to take the reciprocal of the denominator and multiply it by the numerator. And again, the left-hand side stays unchanged. And on the right, I get 5dr divided by 5d minus 3r. And I'm just going to say, what do we do right there? Rational division. All right, it's starting to look a little simpler now. I can now multiply both sides of this equation by the denominator, and I get 5d minus 3r times r plus 10 on the left-hand side, and then I just keep my 5dr on the right. And that is possible because of the multiplicative property of equality. Multiply both sides of an equation by something, and the equation is still true. So a little distributive property here gives me 5 times d times r plus 50d minus 3r squared minus 30r. And that equals still 5dr. And that's from the distributive property. So I can, again, simplify by subtracting 5dr from both sides, and these two terms are going to go away. That's one of the reasons why I didn't bother plugging in the d into my equation yet, because that is the 120 miles for d, because I'm going to eliminate some d's here, and I don't need to carry around these big numbers and do that extra arithmetic before I simplify this thing. So I'm going to subtract the 5dr from both sides, and I'm going to write this thing in standard form, minus 3r squared minus 30r plus 50d equals 0. And I don't like this negative sign on my leading term, so I'm going to multiply through by -1. And that just makes all the negative terms positive and all the positive terms, like this 50d, negative, but it still equals 0 because 0 times -1 is still 0. So now we have a polynomial in second degree that's pretty easy to solve. Let me just say what I did here. The first thing I did was this is because of the subtractive property of equality. And here I just multiplied through by -1. And so that's the multiplicative property of equality. All right, we're getting closer. I'm going to take this over here now. I'm going to need 3 boxes for this problem. This equation here, I don't see any common factors that I can factor out, but now is a good time to plug that 120 miles in for D. And when I do that, I get 3r squared plus 30r minus 50 times 120 is 6,000, and that still equals 0. Now you can see there's a common factor of 3, and so if I divide everything by 3, let me just say what I did here. I substitute 120 for D. Okay? Now I can divide everything by 3, and I get r squared plus 10r minus 2,000. And that equals 0. So let's see, the division property of equality. Now, you can use the quadratic formula at this point. And if you spend too long trying to figure out how to factor this, maybe that's a good idea. But let's think about it for a minute and just try to factor this. What multiplies to make -2,000 but adds to make a +10? And the more you think through it, you may be able to come up with a good solution. I have already solved this problem a couple times, so I know that I can do a +50 and a -40, and those multiply to make -2,000, and when they add, they make 10. So it's not an easy factoring problem, but it is possible. Now I can use the zero product property and say r plus 50 equals 0, or r minus 40 equals 0. That's from the zero product property. And so that leaves me with 2 solutions. R is -50, or r is equal to 40. And there are 2 solutions, and in this case, we just modeled speed as a positive number, so this is our solution, 40 miles per hour. And probably the hardest part conceptually is coming up with this equation, and then it's just a lot of bookkeeping in order to solve it, as we showed in this video. And that's our solution.